Question 8 of exercise 4. Exercise 4.8. A regular polygon has interior angles of 156. So I'm just going to draw part of the polygon. So the interior angle is 156. It's saying find the sum of the interior angles. You can't do the sum of the interior angles because you don't know how many sides it's got. So if the interior angle is 156, the exterior angle is 180 minus 156, which is 24 degrees. So we know that the size of the number of sides. So the number of sides, we know that the sum, of the exterior angles is 360 degrees. So we know that the sum of the exterior angles is 360 degrees. So the number of sides is 360 divided by 24, which is that 15? Yeah. 15 sides. So now what is the sum of the interior angles? There is another way of doing this actually. It's 15 times 156, which is? 2,340 degrees. There is another way you can do it. The other way is as follows. You know how the interior angle sum is 180 n minus 2, and the size of one interior angle, isn't that 180 n minus 2 divided by what? N. Now this is the other way to solve this instead of doing it this way. Okay? But I like using the exterior. So the other way of doing this problem is as follows. We know that the sum of all interior angles is 180 n minus 2. So the size of one interior angle is 180 n minus 2 over n. What do I put for here on the left? What do I write? 156 equals 180 bracket n minus 2 over n. And now I solve this by doing what? Isn't it? 156n is expanding 180n minus 360. And you should work out the number of sides this way. So I've got 180n minus 156n is 360. So I've got, is that 24n? Is 360. N is 15, as we had before. So that's your other way of doing it. So therefore the sum of the interior angles is 15 times 156, which is 2,340. I really think the other method is easier, but you know, there are two methods. So this is method 2. So you've got two methods there. Please, if you're ever stuck with with these types of questions, always remember your exterior angle formula. It really helps you. Okay? Regular polygon with interior angles of 145 degrees. You can do this two ways, a quick way, short way. What do we do? What do you want to do? There are two methods. There's a quick method. If the interior angle is 145, what's the exterior angle? 35. 180 minus 145, which is 35 degrees. Now, how do you work out the number of sides? Number of sides will be what? 360 divided by 35, which is 10.28. Are you allowed to have 10.28 sides? So n must be a whole number to be a polygon. So therefore, no regular polygon is possible. With no regular polygon, etc. You can write your conclusion. So therefore, there is no regular polygon. Now, there's another way we could do this. With interior angle equal to 145. How else could you do it? It's like what we did before. You can either go the exterior method, which I think is very quick, or you can do the one interior angle is 180 n minus 2 over n and solve that, and you should get the same answer. So 145 degrees is 180 n minus 360, actually if I over n, so 145n is 180n minus 360, and then you solve it and you get 35n is 360, so n is 10.28. Again, same conclusion. So there are two ways you can go. We know that the size of one exterior angle is 360 divided by n, so I'm just doing number of sides is 360 divided by exterior angle there, because this is coming from this formula here. Exterior angle is 360 divided by n, all right? A, B, C, D, E, F is a regular hexagon. Show that triangle AFE is congruent to triangle BCD. So what do? That BC equals AF and CD equals FE. Should have them the other way around. Why? Sides of regular hexagon are equal in length. And we also know that angle BCD equals angle AFE, angles of regular hexagon. Now I know we haven't worked out the sizes yet, and so therefore you don't have to work it out. So therefore triangle BCD is congruent to triangle AFE by, what did we do? SAS. Now for part B, show that AE is parallel to BD. I think we need to work out some angle sizes. So let's work out the size of angle BCD. What about one interior angle? So an interior angle of that hexagon, the size of it is what? How do you do it? 180, 6 minus 2 over 6. So the size of one interior angle is 180 times 4 over 6, 2/3 of that, 120. Okay, so why don't we work out the size of angle CBD equals angle CDB. Why do those two angles equal each other that I've just said? Base angles of isosceles triangle BCD. Why is it an isosceles triangle? Because BC equals DC. You have to say why it's isosceles. Because no one told you it was isosceles. You've got to explain why it's isosceles. Unless the question says it's isosceles, you have to explain why. So those two angles are equal. We know that this one in here is now 120. So is that. Okay? So what are the sizes of, so therefore angle CBD, whatever, is going to be 180 minus 120 divided by 2, which is 30. Why am I saying that? Angle sum of triangle. We've already said the isosceles bit already. So what you can do now, what can I do now? And I'm just going to say that angle, we know that angle CBD, well, we already have that. So that's also equal to angle, oh no, that's fine, that'll do. You can do the, but similarly, angle FAE is also 30. Do you know what I mean? So I'm going to say similarly, angle FAE is also 30 degrees. So I'm going to put them in. Now, angle FAB is what? So we know that that's 30, that's 30. Have you got all this? So I'm going to come back over here. All we do, yeah, the angles inside and they're co-interior. So, are we okay with this? So now we're going to go that, but angle FAB is equal to angle ABC, which equals what? What do those whole angles equal? Aren't they 120 because they're just interior angles? Equals 120 because they are both interior angles of the regular hexagon. you get it? So they're both 120, the whole thing. So therefore, see what we're doing? Therefore, angle EAB is 120 minus 30, which is 90. And angle DBA is also 120 minus 30, which is 90. Reason? They're just adjacent angles. Do you know what I mean? Because, yeah, by subtraction. If we're worried, you could go that EAB is, so EAB is FAB if you want, minus, no it's not, yeah, FAB minus FAE. If you want to show the exact angles. And, see, it's that minus that, got it? So now you've got two right angles. So angle EAB plus angle DBA is equal to 90 plus 90, which is 180. And angle EAB, remember what we do now, is co-interior to angle DBA. So remember we say that, yes, these two angles add up to 180, but they happen to be co-interior as well. So therefore, AE is parallel to BD. Reason, co-interior angles are supplementary or add up to 180. Yeah, that's an important one. Yeah, add up to 180 is fine. 3 ways of proving parallel lines are that corresponding angles are equal. You can't do corresponding angles there. Co-interior angles are supplementary, or alternate angles, and I can't do alternate angles here either. So that is the only way I can prove it, by proving that co-interior angles are supplementary. Remember, there are 3 ways to prove parallel lines. You're going to have to find that these are 90 degrees. If you want to show that you've got a square inside, you're going to have to show that these angles are 90, aren't you? But you need more than just showing that those angles are 90. You're going to have to show, because 90-degree angles could mean rectangle. You have to also show that AC equals CE. All right, so what would you do first? It's an octagon. What could you do? The size of this angle here, which is the size of that one. Oh, is this regular? It just doesn't look regular, but it is. Well, it says a regular octagon. So in other words, I know the drawing's bad, but that whole angle does equal the same as angle B and same as angle D. So you would find the size of one angle. Has anyone done that? How do you do? 180 times 6 divided by 8. What do we get? Sorry? All right, good. You can work out the size of one of your angles. And now you can say, therefore, all 8 angles, like even these, like that, are 135. But you can then also prove that 2 of the triangles are congruent, but then make the statement, however, all 4 will be congruent. Okay? Because you've got 4 congruent triangles, we know that AC will equal CE, their corresponding sides of congruent triangles. Similarly, AG equals GE, so the 4 sides are equal. But we need to, that only proves a rhombus, 4 equal sides. We now need to prove that it's a rectangle. You'd have to prove you've got one 90-degree angle. And if we know that, for example, this here is also 135, the whole thing, you can work out that your base angles are 22.5 each. The reasoning would be with isosceles triangles as well. And therefore, you end up with a right angle here in there. That solution on your own. You can check your answers in the back too. In question 14, we've got a regular pentagon here, and they want you to show that AEC is isosceles. Obviously, more than likely, AC is going to equal CE. Again, how would you do it? Proving congruence. Proving that ABC is congruent to CDE. Therefore, AC and CE are corresponding sides of congruent triangles. So you need to say regular pentagon, therefore all the sides are equal. Regular pentagon, therefore, you probably don't need to work out the sizes. Therefore, angle ABC equals angle EDC. So you can say that they're congruent, and these are just corresponding sides of congruent triangles. But then you need to say, therefore, ACE is isosceles because it's got two equal sides. You need to make that statement as well. So if we look here, one sec. Do it with proof and congruence and corresponding sides of congruent triangles, or you could do it using angles and working out sizes of angles. Okay, so that's your other method. So if you want to, you can just do the interior angles 108 equals you've got equal sides of a regular pentagon, sorry. You can use that method there. All right. But if you're saying it's an isosceles triangle, you need to say, oh, because these two sides are equal, or because the base angles are equal. Okay. So it says alternatively, as what we were saying, you could prove congruent triangles and then prove that AC and EC are corresponding sides in congruent triangles. To question 15. So find the size of each exterior angle in a regular polygon of side P. That one's easy. Whether each interior angle is 180 bracket P minus 2 over P. Let's have a look. So find the size of each exterior angle in a regular polygon of side P. How do you do that? Yeah, exterior angle is just 360 divided by P. Oh, sides. Yeah, it's got P sides. So now, doesn't the interior angle equal 180 minus the exterior angle? Because don't they both lie on a straight line? So it's 180 minus 360 over P. So what do I do with that now? What could you do? Do you want to make common denominator? So isn't that actually, yeah, 180P minus 360 over P? You get what I'm doing? Remember, interior plus exterior is 180. So the interior angle is 180 minus the exterior angle. So it's 180 minus 360 on P. Go common denominator, and now just factorize out your 180 on the numerator. 180 bracket P minus 2 over P. Okay? Easy. All done.